Now that we've created an FE model and set boundary conditions, in this case our load case and restraints, we can go ahead and start filling in our topology optimization block. To get started, you can continue working in the file used in the previous optional video, or you can download the starter file below. We'll begin by creating a section titled Topology Optimization. And we'll add the topology optimization block to our notebook. Now we'll add the FE model that we've already created. And this would be the same model from any simulation we've already run in this workflow. Our objective input is where we define what we want to gain out of this topology optimization. Often, we'll assign multiple design responses to give multiple load cases. This is more realistic as most parts aren't subjected to only one load case. To add an objective to our topology optimization, we can double-click and choose Optimization Objective. When applying multiple objectives, we can use this weights input to assign different weightings to each of the inputs. If the weights input is left blank, all objectives will be assigned the same weighting. Our design responses for the optimization objectives can be found in the Topology Optimization ribbon underneath Design Responses. Here, we have 4 different responses: volume fraction, structural compliance, stress response, and displacement response. Additional design responses can be found in the Beta tab underneath Topology Optimization. A commonly used response can be found in our design responses, and that would be this structural compliance response. We can pull this into our design response, and for its load case, we can assign our 2 boundary conditions we established earlier. We'll pull in this fixed restraint and our force. Taking a look at our FE model above, our 2 fixed holes will be these 2 outer holes, and our force will be applied downward on this middle hole. Scrolling back down to our objectives, I'll select that we want to minimize the structural compliance of this entire body. If you want to apply this objective to only one specific region, you can use this optional input. The constraints input in the topology optimization block will most commonly apply a min or max bound to a design response. Like objectives, multiple constraints can be applied to a top-op block. Those constraints can be found here in our topology optimization ribbon, in addition to our pattern repetition constraint, which can be found in our Beta tab. For this example, I'll apply a volume fraction constraint as well as a planar symmetry constraint. I'll set the volume fraction constraint as 0.25. Indicating that our top-op results will have a volume 25% or less of our original volume. I'll use the planar symmetry constraint to ensure that our top-op result is identical on either side of the bracket. To do this, I'll create a plane from normal, and set our origin at the centroid of our design region. Now we can see that this plane from normal splits this FE model down the middle. I'll add these two constraints to our topology optimization block. And now I've finished setting up my objectives and constraints.